Dear friends, I am now moving into another interesting part of analytics, algorithmic thinking for mathematics. I propose to do some interesting problems which will have variety, and I hope you will enjoy. And let me start the series. What is algorithmic thinking? Algorithmic thinking involves solving a problem through a set of well-defined steps, what you call step-by-step approach. So you have got a problem and you will have to find out the solution in a sequential manner, in a proper order, using a step-by-step approach, and that is called algorithm. Algorithmic thinking is the way you frame the solution using a step-by-step approach. Let me start with an interesting problem in calculus where the solution can be obtained using recursive relationship algorithm. Find the nth derivative of x power n log x. That is the question. Nth derivative of x power n log x. Of course, logarithm of x is ln x. That means it is with respect to the base e. Let me discuss the solution. Let in is equal to d power n dx power n x power n log x. In other words, the nth derivative is in the left-hand side represented by in, and using the recursive relationship or recurrence relation, we are going to solve the problem. So first I differentiate this inside the bracket, which is x power n log x once. So in is same as the n minus 1th derivative of d by dx of x power n log x. That means you differentiate x power n log x once. So the outside d power n dx power n minus 1, the n minus 1th derivative, and inside the bracket when I differentiate, it is n times x minus 1 log x plus x to the power n minus 1. If you use the product rule of differentiation, keep log x as it is. What is the derivative of x power n? It is n multiplied by x raised to the power n minus 1 log x plus the derivative of log x. If you keep x power n as it is, the derivative of log x is 1 upon x. So x power n divided by x will result in x to the power n minus 1. This is the expression in the square bracket, which will have to be further differentiated n minus 1 times. Now, if you look at this inside, x to the power n minus 1 log x, if I differentiate, of course, n is outside, n times x to the power n minus 1 log x. If I differentiate n minus 1 times, it is same as n times in minus 1. The first expression, d power n minus 1 dx power n minus 1 nx to the power n minus 1 log x will result in n times in minus 1. Then the n minus 1th derivative of x power n minus 1 is factorial n minus 1. All of us know the nth derivative of x power n is factorial n, and therefore the n minus 1th derivative of x to the power n minus 1 will be factorial n minus 1. So in is equal to n times x to the n times in minus 1 plus n minus 1 factorial. Now, dividing both sides by factorial n, you get in divided by factorial n is equal to in minus 1 divided by factorial n minus 1 plus 1 upon n. Because when I divide n minus 1 factorial by n, I will get 1 upon n. Now, similarly, by recurrence relationship or recursive, I repeat it, in divided by n factorial. I'm sorry, before I do that, I arrange it, bring the expression of in minus 1 divided by n minus 1 factorial to the left-hand side. So in divided by factorial n minus in minus 1 divided by factorial n minus 1 is equal to 1 by n. This is what I get. Now, in a repeated manner, and therefore I can say in minus 1 divided by n minus 1 factorial minus in minus 2 divided by n minus 2 factorial is equal to 1 upon n minus 1. I can, in a repeated manner, similarly, I can do. Similarly, I can write in minus 2 divided by n minus 2 factorial minus in minus 3 divided by n minus 3 factorial is equal to 1 upon n minus 2. Now, etc. I go, then I2 by factorial 2 minus I1 by factorial 1 is equal to half. Now, I1 by factorial 1 minus I0 by factorial 0 is equal to 1. Now, the interesting part comes. Of course, factorial 0 is 1. Adding vertically, if you keep adding the expression vertically, the second term in all the expressions when I add will get cancelled. And what you get in the final end is in divided by factorial n minus I0. Only that will remain. Till this part, everything will cancel on the left-hand side. In divided by factorial n minus I0 is equal to 1 plus half plus 1/3, etc. plus 1 upon n. Of course, we can say 1 upon n plus 1 upon n minus 1, etc. 1. I just write it in the reverse order, 1 plus half plus 1/3, etc. plus 1 upon n. Therefore, in by factorial n is equal to I0 will be taken to the right-hand side. I can write it as I0 plus 1 plus half plus 1/3, etc. plus 1 upon n. Now, what is in? If I take n factorial to the other side, in is therefore equal to n factorial into log x plus 1 plus half plus 1/3, etc. plus 1 upon n. I0 is log x because in is equal to x power n, the nth derivative of x power n log x. Let me just show you the first slide here for you. In this, if I put I0, it will be the 0th derivative of, that means I don't differentiate. X power 0 is 1, so I0 is log x. So that is what I have said here, and therefore the nth derivative, which is represented by in, the subscript n, in equal to factorial n into log x plus 1 plus half plus 1/3 plus etc. plus 1 upon n. And we have solved the problem, the nth derivative of x power n log x. Thank you very much. We will see you in another video as soon as possible. Thanks a lot.